The final coordinate system transformation is scaling, which changes the size of the grid. Take a look at this program, which draws a square, then scales the grid to twice its normal size and draws the rectangle again. The x and y coordinates of the second square have been doubled, as have the parameters for width and height. You can see that in the code here. This is the original smaller rectangle. It hasn't been affected by any transformations. And then over here we have the second rectangle, and scale is used to double its coordinates, double its size, and double its stroke weight. You can see that the square appears to have moved, but it hasn't, of course. Its upper left corner is still at 2020 on the scaled up grid, but that point is now twice as far away from the origin as it was in the original coordinate system. If you wanted the large square to start at the same corner as the small square, you would translate first, then scale. Because the scale here is actually scaling the 20s, it's doubling them to 40. So we just need to set those to 0 and translate before we scale here. 2020. And look at that, it's right there at 2020 and scaled accordingly. Just what we wanted. You might also notice from both of these programs that the lines are thicker on the large squares. That's no optical illusion. The lines really are twice as thick because the coordinate system has been scaled to double its size in all different ways. You could explicitly change the stroke weight to account for that, or avoid using scale altogether. The scale command optionally accepts 2 parameters instead of just 1, so you can scale the x and y dimensions separately. Let's try using scale 3 for the x amount and 0.5 for the y. Oh, and translate to the right. What we're seeing here is what we would expect. The strokes here in the x direction have been tripled, and in the y direction, well, yes, the width has been tripled as well in the x direction, and in the y direction, everything has been split in half. Another thing scale can be used for is flipping images or any other object. It's really interesting. I'll paste in some code, new code. I have Hopper over here. He's drawn, he is drawn on the right side of this line, and I'm going to use scale to flip it over on the left side of the line. We can see here that the image is drawn at 0, and we translated 200 before that. So what I'm going to do is use scale, but actually give it a negative x value for the amount, and then just a normal 1. You may be wondering why I'm using -1, but I'll explain that in a moment. Copy and paste first, and we have our image drawn again. So the -1 kind of looks odd, but it makes sense because what scale does is it just moves the right side of Hopper. Look, we already drew the image at 0, so all that moves is the right side of Hopper. So if you scale it in the x direction, the right side will move. But when you reach 0, the right side continues to move to the left if you go into negative values. So all of the pixels that draw Hopper are just moved to the left and inverted. Isn't that cool? It's so simple too. You can do this with other images, shapes, and lots of other cool things. So that's how we can use the scale function to resize shapes, images, or the canvas. We can also flip objects with it, which is a very cool feature. Scale can be very helpful, especially when you're drawing a complex picture with perhaps hundreds of shapes. It's difficult to set those shapes' widths and heights to a fraction of some size variable. A simple scale command can replace all of that very easily, and we're always looking for ways to always looking for shortcuts that can lead to less complicated code. So be sure to add scale to your coding toolbox. Hope you enjoyed. I'll see you in the next video.